Hello and welcome to another episode of Anything Arduino. Today and a few episodes ahead we are going to discuss RGB LEDs in different kinds and forms and stuff. This because it is one of the most used applications for the Arduino. If you look online, everyone uses an Arduino to blink or flash LEDs. So we're going to begin with a really simple one, the RGB LED, no extras, anything, just using 3 pins on the Arduino and to show LEDs or colors. And also, here's another type. You can get the module like this or just 4-pin LEDs like this. And the reason we're going to do this is because I want to add some. In the bottom here I have an acrylic pane which I want to add an LED to have some visual feedback in my multimedia controller, which we did in the last episode. So with all this said, let's go into the theory of RGB LEDs.
The theory behind Rgb Colors is that by combining these 3 R, red, G, green and B, blue, you can from these colors get any other color of the color spectrum. And when I say color, I actually mean light, so colored lights. And usually so if anyone of you ever have been inside the Paint app on Windows, then you have the button Edit Colors, and in here you can move this little cross point around to get different colors. And so you have red, green, blue in Swedish here, but it's red, green and blue. It's all 0, 0, 0, and this is because we have chosen the black color. But if we go up a bit here, then we can see that the values of the red, green and blue are changing. And if we go all the way up to red, then we see that red is at 255 and green and blue, because we have, so we can go down a bit here, so there is pure red. And then we can move over to almost there, pure blue, red and green is there. So red, green and blue. And in between these you have yellow, so that is 255, so maximum color red, maximum color green, and no blue becomes yellow. And purple is red and blue all mixed, and cyan is green and blue. And so all the colors with these 3 bytes. So these values, this is a very good way to find the color that you want once we start programming the Arduino. So if we want purple, we can remember so this purple is 249, red, green 0 and blue 255. So let's go into the Arduino and I'll show you how to do this with an RGB there. The easiest way to explain this is to open an example, the basics fade sketch. So the fade sketch is just fades an LED on pin 9 using the analog write function. Now pin 9 is a digital pin if you look at the Arduino. So what the analog write function does is it does a PWM write to the pin. PWM stands for pulse width modulation, which technically means that you send pulses of 5 volt, between 5 volt and 0 volts, so a square wave. You send that on the pin really fast, which gives the impression of a fade, because it flickers so fast that the eye can't see the flicker. This emulates a value between 0 and 255. So in the example code for the fade, we only have one LED on pin 9, which is one of the digital pins that has PWM capacity. The pins that have PWM is pin 3, 5, 6, 9, 10, 11. So 6 pins with PWM. So we have the LED pin 9 and brightness is at 0, so that is off or black in this case. So we analog write to the pin 9 and the brightness, and then we fade up the brightness until it goes up to 255, 1 byte, and then it goes down. So this will fade one LED up and down. Now we're gonna do this but without the fading, so we're gonna do like this. Red. So now we have 3 LEDs, the red, the green and the blue. Then we're gonna get values for these because we only want to show one color. So now we have the value for black. Again, we're gonna change this in a moment. We have set up our LEDs, and then we're gonna do an analog write. And we don't need any of this. So this will just set the color that we set according to these colors here. So let's say we want purple, and then again when we looked in here we saw that purple, depending on how much purple we want, was 255 and 255 red and 255 blue. We upload to the Arduino and let's connect an LED. Searching on the internet, you find a lot of pin out diagrams for RGB LEDs, and this is one of the ones I found. However, everything on the internet isn't always true that you see, and so is the case here. So it says R for red, most to the left, pin 1, then minus or plus, depending on if you have a common anode or common cathode. Green, blue. So you can try it out by just putting the voltage over the pins to see which color is which. So in this particular case, this pin is blue and this pin is green. So for the LED we're using in this project, those 2 pins are switched. So good to know that. Try this out before you solder anything together, because once you've done that, it's too late. Connecting this is quite easy. We begin with the red pin. We connect that to an 82 ohm resistor, and we connect that to pin 9. We then take the blue pin and connect to 150 ohm. These are just some values that can be used for these colors. As I said before, the LED, RGB LED module that I showed has all 330 ohm resistors on it. And if one color is more dim than the others, you can switch these resistors for other values. But in my case, I use these values. And the green pin to another 82 ohm resistor. Connect that to pin 11. The blue one to pin 10. And the red pin was pin 9. And ground, of course, connected to ground. 150. And now now we take a white piece of paper and we see that this is purple. And this we can, by using MS Paint, we can do this with all the colors to find what color we want our LEDs to be. So now let's incorporate this into our code for the multimedia controller, and let's see how that becomes. So that is what we are looking for, a shine around the edge. So let's look at that code instead. So we're already running into some problems here. If we remove this shield, I don't know if you can see in the camera, but we are actually missing, so there's pins 2 through 9 down here, and then we have pin 10 over here, and then we are missing 11, 12, 13, and 14, 15, 16 are still there, but 11, 12, and 13 is missing, and we would need to use pin 11 from the other sketch. So, and also pin 9 is already used by the button. So I need to have, I can use pin 10, we have a header already there, but I need, so pin 6 is already in use as well. So I need 3 and 5, so I need to put another header in here and solder that, along with some cables in the right colors that I have prepared. So I'm gonna do that and then the code. Here's the final soldering. So I added ground, red to pin 3, green to pin 5, and blue to pin 10. And then I added that to a small breadboard where I added the resistors and the LED, RGB LED. And I've also done some preparations in the code. So in the encoder and button and multimedia together, double check with com. In that code I've added these lines, are green, blue, sorry, that one as well, red, green, and blue LEDs, 3, 5, and 10. There are something called Rgb Timer and a small start sequence using start LED. So to fire up the color I want, I have down at the bottom, I've done a small function called RGB LED, where I pass a red value, a green value, and a blue value, and also how long I wish this to stay on. And this is because we use buttons, and there we can't have any delays and stuff like that, again, as I explained in the last episode, because of how the encoder works. So what we need is we need another timer to check how long the LED should be lit up every time I press or turn or whatever I do. So
in the beginning of this function, so if the RGB time is sent in the function is not 0, then we set another an int as well. The RGB timer, we set it to millis plus the RGB time sent within the function. Then we analog write the values to the LEDs, so we light them up. Now, going back in the setup, I also added these pin mode for red, green, and blue LEDs. And the first thing that happens in the loop now is the RGB time check. So that is the next function, which was below. And this is that function, RGB time check. We don't pass any commands. So if the RGB timer is larger than 0, so if there is a timer, the timer is set within the RGB LED function from this time, so from now, whenever we start up the color, and plus the time we want it to shine. So if it's larger than 0, then we check if millis now is larger than the time we set in the RGB LED function. If it is larger than that, then we set the RGB LED, so we call this function, but with a 0 as the time. And this is because we don't want to set the timer again. So if RGB time is not 0, then we set the timer, but we send the timer here, so we don't set the timer, and instead we set the timer on the next row, so it's equals to 0. So with those two functions, we can now do things like this. So I just want to light the LED with white color, so all the 255, 255, 255 for 1 second, so 1000 milliseconds. And if start LED equals 0. And if it's equals to 0, we do this once, and then we set the start LED to 1, and we won't do this anymore. And if we upload this sketch to the Arduino, we should see the LED flash for 1 second, and then go dark again. And there it went. So with this, we can now add the RGB or the colors that I wish for each function. So I've added a couple of colors. I don't know if these are good colors for what I want, but they are added, and let's try this out. So there was the start, and we press this one, so this should be play. Green, yellow, and volume up is red, volume down is blue, and let's hold it in, and so next is purple, and previous is orange. It's supposed to be orange, that one. So that works awesomely. Great. So let's add all this together again. Let's see if we can fit it all as it should be. So here's the trick. There is just enough space, so we should be able to cram it in there somehow.
like so. Look at that. And some hot glue to keep this together. Let's do that. Let's dim the lights a bit. Because what happened here is that the integer of the timer went through the roof, of course. We can't have an int for the RGB timer. We need to have a long. And now it should work much better for a longer time. And here you see it is actually orange, red, blue, play, and yellow pause. Really nice. And the encoder works as it does. A few ups and a few downs. Mostly downs now, and up. And with that, I am quite content with this multimedia controller. So now it has lots of functionality in a simple package, and also a lot of visual feedback for what it's doing. The only thing I didn't get it to do was to play pause next YouTube videos, but that apparently needs a lot of plugins for your web browser and is a big thing with all multimedia controllers, so not specific to Arduinos and this controller as such. So I hope you now know how to use RGB LEDs, the old school style, and that you can incorporate that in your projects. Also, we looked a bit on functions and how to use that. I forgot to mention that the variables, so we use local variables to set a global variable. The RGB timer is a global variable, therefore we can use it outside the function, while the values was for the RGB settings was local, just inside the function. This is a really short explanation of functions, and local and global variables just needs a lot more explanation than this, but just wanted to share that as well. In the next video we'll look at the TLC5943, a chip that will make it possible to use more LEDs and RGB LEDs and control them with one Arduino, even though we don't have enough PWM pins. And with that said, I hope you liked this video. If you did, leave a thumbs up. If you haven't already, subscribe, and I'll see you in the next episode. Bye.